Okay, so good evening, friends. Welcome to Unit 2, Lecture 2, where I'll be teaching you integration today. So, integration is basically anti-derivative. Whatever we learned in the last class regarding derivatives, all the formulas, just think it's the reverse of it. Okay, so integration. So here integration, we will be learning the formulas first, and it's very easy because whatever you have learned in derivation, all the formulas you just have to reverse it. So as you can see on my screen, differentiation of x to the power n, as we learned, is just a reverse x to the power n plus 1 by n plus 1 plus c. Okay, one thing before going ahead with the formulas, I want to say integration is of two types. One is indefinite integral and one is definite integral. What is the difference basically in between this? Indefinite integrals will not have a limit, uh, lower limit and upper limit between which it will be calculated, and at the end this 1 plus c one constant will be added. This is the integration constant. Okay, and in terms of definite integrals will come, we will have some limits and some properties to solve the sums easily and quickly. Okay, and we will have some values. Okay, so let's start with indefinite integrals. So here are the formulas. First one is integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1. I mean, if someone gives you a sum of x to the power 10, so it will be in place of n, you have to put it 10, and answer will be x to the power 10 plus 1 x to the power 11 divide by 11 plus c. Never forget this plus c will be here. Okay, it will always be here basically. Then comes integration of dx. It is x plus c, nothing. Like as we learned in differentiation, ddx of x, differentiation of x is 1. Here same. Here basically it is 1 dot dx, 1 into dx, and it's integrated to x plus c. Then we learned differentiation of sin x is equal to cos x. Hence reverse. As I said, integration is reverse. So integration of cos x dx is sin x plus c. Then when it comes to cos x, it will be minus sin x. So here it will here integration of sin x will give you minus cos x. Similarly for tan x, with when in terms of differentiation it gave sec square x, so in integration it's again reverse. Sec square x dx is equal to tan x plus c. Similar in minus cot x is equal to cosec square x. In differentiation and in integration, integrating cosec square x dx will give you minus cot x plus c. Then ddx of sec x is equal to sec x tan x. Then integration of sec x tan x dx is equal to sec x plus c. Then comes integration of cosec x cot x dx is equal to minus cosec x plus c. Integration of dx. Acha, these are all inverse trigonometric functions. So differentiation of inverse trigonometric functions, it's same just like the before. You have to just do reverse and integration will be done. Integration of dx by 1 by root over 1 minus x square is equal to sin inverse x plus c, and the same will be for cos x, just there will be a minus cos inverse x plus c. As I told you in the last differentiation class, there is a trick of I mean remembering this, memorizing them in pairs. Just a difference of minus will be there. Similarly in integration you can do this. See, for sine and cos, both are same, just you have to add a minus with cos inverse x. Similar in case of tan and cot, it's dx by 1 plus x square integration is equal to tan inverse x plus c, which will be again equal to minus cot inverse x plus c. See, this LHS is same for both. So you have to just think that these two tan and it is minus of cot. Again in when it comes to sec inverse x and minus cosec inverse x, is value is same. Integration of dx by x of root over x square minus 1. Then we learned that in differentiation of e to the power x gives e to the power x only. So in integration with, again it will be same itself, no change. E to the power x dx is equal to e to the power x plus c. Then integration of dx by x is equal to log mod x plus e. Well, this mod now, this it will always give positive value. Okay, that's the function of modulus. Then dx of e to the power x by log a is equal to e to the power x. So in integration, again it will be reversed. Differentiation of a to the power x dx is equal to a to the power x by log a plus c. Let's see some sums based on the formulas we just saw above it. So here we have to find the antiderivative. Don't just get scared. Antiderivative just means integration. You have to integrate all the given questions. So cos 2x. So what we learn, what is integration of cos x? Just see here. Integration of cos x dx is equal to sin x plus c. So obviously integration of cos 2x will be sin 2x. One thing that's different, whenever you will have a coefficient of x here, like here is 2x. So when you will integrate, it will come sin inverse 2, sin 2x, not inverse, sorry, my fault. Sin 2x, just you have to divide it by 2 again. It's just a general formula, it's like this. If I show you here, just remember it like this. Integration of cos or any value here is equal to sine, acha, here it will be a dx, sine ax, okay, divided by a plus c. See, the thing is, if it comes e to the power ax, okay, dx, then what will be the answer? It will be same, e to the power ax only, just a will come again in denominator plus c, which is a must. If you don't give this plus c, you will get a big zero. Okay, so that's the thing. So let's go to the next one. 3x square plus 4x cube. So what we learned, let's see here the formulas. Integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1. So in place of n, see just the coefficients will be separated. You have to write the coefficients, obviously there will be no change. You have to integrate this x cube plus x to the power 4, and what will it give? X to the power 4 by x to the power 3 by 3. Again it will be cancelled, plus x to the power 4 by 4. So the denominators and the numerator are same, so they will be cancelled, and the answer will be x cube by x to the power 4. Lastly, 1 by x. Well, last class in differentiation I told the differentiation of log x, ddx of log x will give 1 by x. So if we integrate 1 by x, definitely it will give again log x itself. See, and that's the answer. Well, one thing, do not forget, there will be a modulus. It will be positive value. Okay. Let's go to the next one. Okay, here is that thing which I just which I have shown you just a minute before in the whiteboard. Sin mx. Here's a coefficient of x. Just see here, and that's m. So we learned that integration of sin x dx will give minus cos x plus c. So when there will be an m, only difference that will come is minus cos mx divided by m plus c. Job done. Next question is 2x sine square, sorry, 2x into sine into x square plus 1. Okay, so to do this sum, you have to just use a substitution, which I will show you further while teaching you the methods of integration, where we do integration using substitution, where you have to use certain variables, unknown external variables, to adjust the question without affecting the question itself. You know, it's just adjusting and simplifying the question to your own ease, so that you get the right answer without actually changing the meaning of the question. Let me show you in this question how it's doing. So x square plus 1, it's a kind of weird stuff here, right? So just substitute it something simple and just see how can you know, do not change the meaning of the question. So when we will write it in question form, what will it be? It will be integration of 2x sine x square plus 1 and dx, right? So just we have to do something, with this stuff, so that we can make this entire equation, this entire question very simple one. Let's just assume it to be t or u, whatever alphabet you like, your first, take your first letter. So it will be sine t, definitely. Now differentiate this one, x square plus 1 gives t, right? So what will it give? Differentiation of constant 1 is 0, but differentiation of x square is 2x dx, and it will be is equal to dt. Okay, so this 2x and dx will change to dt, and it will become sine t integration of sine t dt. Now it's very simple. We have learned what's the integration of sine t, right? It's minus cos. It's minus cos t. So see, they have done just the same. X square plus 1 is equal to t. Here 2x dx is giving dt. It's getting adjusted, but the question itself is not changing. Now integration of sine t dt, and sine t integration is minus cos t, and in place finally in the answer they are replacing the t, minus cos x square plus 1 plus c, job done. Then take another sum. Okay, this one is a okay. I am just explaining you both of these. Understanding both of these might help you in further questions. See, here we have tan to the power 4 root x sec square root x by root x. Now we have to do like this. Root x is a bit weird stuff. Just do something with this. Okay, so let's assume it to be again t, or your first letter, take it, differentiate it, and just see what value is coming. See, they're just done the same. They have taken it to be t, differentiated both the sides, and they have simplified it. They have simplified the integration of 2t. This t and t will get cancelled, and tan to the power 4t sec square t dt. But here one tragedy is there. You have to take another substitution. Substitution of what? Sec square t dt is du. Why? Why? So means you have to take this tan. Okay, tan t is equal to u, because we have learned in integration formula what it gives in while differentiating, it gives x squared t dt. Okay, so see how much simplified they have done it. They have totally transformed this into u to the power 4 du, and this into 2. Then the final answer is u to the 2 into u to the power 5 by 5 plus c, and they just replace the value of u to tan root x, and they got the answer. If you wouldn't have substituted by t or u, you would have, like, it would take pages after pages and you won't be able to solve it. That will be a huge calculation. To simplify it, we are using method of substitution. Then the fourth question, right? Where is the fourth question here? Well, here it can be just clearly seen. We have just learned integration of dx by 1 plus x square is tan inverse x. So if we just take this to be u or t, this entire part will become the differentiation, and it will be just sine u du, and it will be minus cos u. So they just replace the final value minus cos tan inverse x plus c. Here c, they've just done the same. They have taken it to be t, they differentiated this, and they got it dt, and then integration of sine t dt, then minus cos t plus c, minus cos tan inverse x plus c. Okay, so now just get some more formulas which will help you further. Integration of tan x dx will give log mod of sec x plus c. Never forget about this mod. And these proofs are generally not required, so don't go for them. Just try to memorize, mark up the formulas. Root over cos x dx is equal to log of sin x plus c. Root over sec x dx is equal to log of mod sec x plus tan x plus c. Then integration of cosec x dx is equal to log mod of cosec x minus cot x plus c. Okay, so let's just do one or two sums. Yeah, just let's have one sum. See, here is a question: sine a cube x cos square x dx integrating. So what they did, they just separated one sine x from sine cube x and made it sine x here different, and changed this sine square x into 1 minus cos square x into cos square x into sine x dx. Now what they did, they just made this cos x to t, and dt will give minus sin x dx. So they just replace it with minus of integration 1 minus t square into t square dt. Now what it is giving? It's simply giving t square minus t to the power 4, as we have done the formula of x to the power integration x to the power n. Okay, it where it was x to the power n plus 1 divided by n plus 1. So in place of x, it's just t. They just applied the formula two step and they got the answer, and replace it with t. Never forget to replace the substituted value. Okay, again, or else it will again cause a big issue. You will get a 0. Okay, then some more formulas. Integration of dx by x square minus a square is equal to 1 by 2a log mod of x minus a by x plus a plus c. Then this one, integration of dx by a square minus x square is equal to 1 by 2a log a plus x by a minus x plus c. Integration of dx by x square plus a square is equal to 1 by a tan inverse x by a plus c. Integration of dx by root over x square minus a square is equal to log of mod x plus root over x square minus a square plus c. And integration of dx by root over a square minus x square is equal to sine inverse x by a plus c. And final formula, integration of dx by root over x square plus a square is equal to log mod of x plus x square plus a square plus c. Okay, just see the formulas related, see the sums related to these formulas. Take the first question. Integration of dx by x square minus 16. Just see in that formula what we have learned, in place of a it will be 4. Okay, because integration of dx by x square minus a square, it is that formula. So you have to apply 1 by a 1 by 2a log mod of x minus a plus x plus a by x plus a. So in place of a it will be 4 x square minus a square. That form has come, and just directly write the answer, this one. Then this, well, you have to adjust here again something, or else you won't get the proper formula for it. Just see how they've adjusted. Integration of dx by root over 2x minus x square. So what they did, you have learned the formula of x minus 1 whole square, right? X squared minus 2x plus 1. So just put a minus in front of them, it will get reversed, and 1 minus, and it will be adjusted. And then they have taken this one to be t. This is a square minus t square, and the formula is sine inverse x plus c. So x minus 1, sine inverse x minus 1 plus c. These are the same numericals based on the same form. These are the numericals based on the same formula. Okay, just see the first one itself, and the rest one are all depended on the adjustment that I've shown you. Okay, so integration of dx by x square minus 6x plus 13. So just see how they are adjusting it here. What is this? X square minus 6x. 6x is basically 2 into 3 into x, right? So here it should be x square minus 6x plus 9 plus 4. But there when you are adding a minus 9, question is changing. So to adjust it, you just have to add another minus 1. So here it is. They have done it. X square minus 6x plus 3 square minus 3 square, just to adjust it, plus 13. And see, this 3 square is 9. So minus 9 plus 13 is plus 4. Here it is. And they have got the entire formula for x minus a whole square, x minus 3 whole square. Then they replaced it here. 1 by x square plus a square. And then you know the formula, 1 by a tan inverse x by a plus c. And then they have replaced it and got the value. So these were some normal methods. Now let's go for some bit weird stuffs of integration. I really find it weird, but once you know the formulas, you can just solve all of this. These are all based on formulas. Just a bit of a creativity is required to use the adjustments, and you can solve any sum of integration. It's not a big stuff. Okay, so this is called basically partial fractions. Okay, so for partial fractions, some five common forms are there. You will always get the questions out of these five common forms only. The thing is, using these forms, you have to use the formulas on the right side. Well, these are not formulas. These are like breaking them a step, the next step made easy for you here. And what you have to find, I'm just showing you. So when it will be given px plus q, it's divided by in denominator x minus a into x minus b. So you just have to break it into a by x minus a plus b by x minus b. Why? Where this px plus q has gone, I will show you. Just have patience. Then px plus q by x minus a whole square gives a by x minus a plus b by x minus a whole square. Then px square plus qx plus r divide by x minus a x minus b into x minus c. So again they are breaking it into a by x minus a plus b by x minus b plus c by x minus c. Then number 4, px square plus qx plus r gives x minus a whole square into x minus b, which gives a by x minus a plus b by x minus a whole square plus c by x minus b. Then px square, fifth form, px square plus qx plus r, which gives px square plus qx by plus r divided by x minus a into x square plus bx plus c. It gives a by x minus a plus bx by plus c divided by x square plus bx plus c. So let's just try out some sums out of this. First sum, integration of dx by x plus 1 into x plus 2. You have just seen it here, right? This one. Just compare it. You have to learn this totally and compare the sums you have got. So you will directly write it a by x plus 1 plus b by x plus 2. Okay. Now just crisscross, do LCM and do crisscross. A into x plus 2 plus b into x plus 1. And now compare with the form that you have got here. See, so you will get simultaneous equations where you will have two unknown variables we have to find out, that is a and b in this case. Others, like in the third, fourth and fifth, you will have three unknown values to find out, a, b and c. So there will be obviously three equations again. So here you have to find out a and b, then put it in this value and integrate it. So it will be solved in just c. It's taking merely 3 to 4 steps and you are just getting the answer using the forms that have been given. Then this one, x square plus 1 by x square minus 5x plus c. Now here you have to again do some adjustments. Okay, so what adjustment is done? I hope you guys have learned about dividing with in these quadratic terms and all. Okay, this is not a proper rational function basically. So what you will do, you will divide this x square minus 5x plus c with this numerator and see what result you are getting. You will get this 1 plus 5x minus 5 divided by x square minus 5x plus 6. Then you will break this into x minus 2 into x minus 3. This 1 minus this one will be separated, and then you have to calculate just like the previous sum and integrate it, and you will get the answer as x minus 5 log mod x minus 2 plus log of x 10 into log of x minus 3 mod plus c. Then this one, here you are getting in this sum the three unknown values a, b and c. Simply use it in the form a by x plus 1 plus b by x plus 1 whole square plus c by x plus 3 and crisscross them and do compare. While comparing, you will get three equations. A plus c is equal to 0, 4a plus b plus 2c is equal to 3, 3a plus 3b plus c is equal to minus 2. Then you have to solve the three equations, get those three unknown values of a, b and c, put them again in this equation. You will get a proper form. Then you will integrate them and you will get the answer as 11 by 4 log mod of x plus 1 by x plus 3 plus 5 divided by 2 into x plus 1 plus c. Simple. You just have to know the expressions in which it will be, the sums will be given. If some adjustment had to be required, you have to do it and to go ahead with the forms and compare and get it done. Okay, so till here we were doing all the indefinite integrations. Okay, now what we will be doing is definite integrations. Now what is this definite integration? You know, in when definite integration comes, you will get some limits and some particular properties which you have to use to make the complex sums easier to solve them in a very quick step. Let me just show you what is like definite integration. Just take a sum here itself. Just take this one. I'm saying this one. Suppose the lower limit given here is 1 and the upper limit given here is 2. So when this will be given, plus c won't be written. Now this is not required. It's not. Now you have to just put the values. Upper limit 2, lower limit 1, and put them. So first will be e to the power 2x. Okay. Okay, I'm doing some step. Wait a sec. X to the power 10. We have to put the value in place of x and not a. But in hurry, I just made that mistake. Sorry for that. So when it is indefinite integration, you are doing like this. Sorry, x to the power 11 divide by 11 as per formula plus c, right? Now, when you will be given a limit, a lower limit, for example, 2 and it's 3, this constant is of no use now. You have to just put it 3 to the power 11 by 11 minus 2 to the power 11 and you have to calculate it. Calculator is used while calculation, so there is no issues. Upper limit minus lower limit. Well, if you find this to be complex, let me just show you in a more simpler way. Integration of dx, the simplest that can be done in integration. In terms of indefinite, it will be x plus c, but when we are just adding limit, suppose 1 and 2, well, this is the upper limit, this is the lower limit. Obviously this constant is now not used. It will be 2 minus 1. Answer will be 1. Okay. One thing that I have forgot to mention. Okay, this is basically how the definite integrals are calculated. Just calculate it and then put the values upper limit minus lower limit and job is done. Well, one thing I have forgot to tell you is that is integration by parts. So what is integration by parts? When more than, see, suppose if you get a sum like this, x cos x or x to the power x into e to the power x, or x cos x, like completely different thing which you cannot do by, or like this, yeah, this kind of sums. What you will do, we have to follow an order and integrate them, and I will give you the formula for integration. Firstly, follow the order. Let I, L, A, T and E. Here E means exponential, T means trigonometric, A means algebraic, L means logarithmic, I means identity. and I means inverse. Okay, so okay, sorry for the glitch, it was a technical glitch in between, so there's a pause. So inverse, so like this, it can be like this also, x cos inverse x. Okay, you have to solve in this order, like this one is the uppermost and this one is the lowermost. So you have to do like this, that you have to keep the upper one, integrate the lower one, minus a big integration, keep the upper, then ddx of, then inside you have to differentiate the lower function, and then integrate the whole function. Well, you just have to see one thing for integration, the one h can be integrated repeatedly, can be used inside. Okay, so that's it, that's how easy to it. Okay, so in this way you have to do integration by parts. So here it is like x is algebraic and t is trigonometric, so x will be outside and cos x minus integration of again x and ddx of cos x, then integration of whole part of dx, and you have to solve it. That's how integration by parts is done. Okay, so this was all about the indefinite integration. Now some properties of definite integrals. So using these properties will make the sums very easy. Okay, so what does the property says? Okay, first property, integration a to b fx dx gives ft dt. Simple, just if you change the values the answer will be same. We know this from beforehand only. Okay, when it will like change the values, sorry, not the values, the limits, like when upper becomes lower and the lower becomes upper, the value will come in minus. Obviously when you will do like 2 minus 1, it will give 1, but when will you do 1 minus 2, it will be minus 1. Simple, that's what is shown here. And if limits are same, answer will be 0. Okay, then limit a to b fx dx gives limit of a to c fx dx plus c to b fx dx. What is it? Like you are breaking it in between somewhere to make it continuous, to simplify the sum, and you know, if it's big enough, another value. Then property number 3, integration a to b fx dx is equal to integration a to b f of a plus b minus x dx. Now you know what? This is actually the king's rule. Like you, this property, this third property, and the fourth one is just the modified version of the third property. Using this, you can solve literally any numericals out there. Okay, any integration means most 90% integration can be solved using this only. This is the most important. Like third and fourth, just mark it up and don't dare to even ever forget it. Okay. Then P5, property number 5, 0 to 2a fx dx gives 0 to a fx dx plus again 0 to a f of 2a minus x dx, just to make it continuous. In 0 to 2a fx dx give 2 of 0 to a f of x dx. Just remember these formulas and apply them accordingly. I will just show you the sums below. In the seventh one is for even and odd function. My integration minus a to a fx dx gives 2 into 0 to a fx dx. It's an even function. Okay, like f of minus x is equal to f of x, and in case of odd function it will give 0. Okay, f of minus x is equal to minus fx. Well, you can just you remember that cos x, that when we do cos of minus x it will give cos x only. That's an even function. But when we do sine of minus x we get minus sine x, so that's an odd function basically. Okay, now let's go to a numerical, an integral is given 0 to pi x sin x is by 1 plus cos square x dx. Okay, Just see here again the King's rule is being applied. A minus B, A minus 0. See, the King's rule is applied here in place of x. Just replace the x with the King's rule property. What just told in the King's rule? See, 3 and 4. 0 to a f of x dx is equal to 0 integration a to 0 to a f of a minus x. You see, it's simple. It's done same. A minus x. Here a is pi minus x sine of pi minus x dx by 1 plus cos square pi minus x. What's it giving? Now break it. 1 is pi into integration 0 to pi sine x dx by 1 plus cos square x minus I. You are just indicating this as I. Integration I is equal to this value. So you are again getting the same thing here. On doing minus x sine x by 1 plus cos square x. Okay, pi minus x is cos square of pi minus x is cos square x itself. So it's coming I. Now this minus I will go this side and it will become 2i. Now 2i is equal to pi into integration 0 to pi sine x dx by 1 plus cos square x. Now we have to again use that adjustment stuff. Put cos x is equal to t, so that when you will differentiate it both sides, you will get minus sine x dx dt. Just see here, if when you are replacing this with t, you are getting this as dt. When you will do this now, what, just keep one thing in mind, you have to change the limits also as per that. So when x will be is equal to 0, t will be 1, and when x is equal to pi, t will be minus 1. How you will get it? You just have to put the values and see what is coming. Like x equal to 0 means here this 0 is, you have to put it, because cos x we're changing, right? So cos 0 will be equal will be 1, and cos of pi will be equal to minus 1, and that's how the value is changing from 0, from 1 to minus 1, and from minus 1 to 1. Okay, and then they just integrated it using those formulas which we learned in terms in case of indefinite integrations, and answer is pi square by 4. Well, now the miscellaneous examples and the revision of integration will be done. So in question given is integration. Well, this is indefinite, both of them, that's given here. Cos 6x root over 1 plus sine 6x dx. So they have just taken this as 1 plus sine 6x as d, and then differentiated both sides. They got value for this. So 1 by 6 integration t to the power root over t dt, and integrated it. Well, here if you add a value, what to say, limits, not values, limits, like pi, minus pi, 0 degree, anything, then it will, this answer will come in a value. Like you have to then replace this x with the concerned limits, and take out the particular answer. In this sum, just see, they have adjusted this again in the second step. So x to the power 4 minus x whole to the power minus 1 by 4, x to the power 4 minus x whole to the power 1 by 4 by x to the power 5 dx. Okay, now they have adjusted it 1 by 1 minus 1 by x cube to the power 1 by 4 by x to the power 4 dx, and then they have taken this to be t and differentiated. They got the replacement for dx by x to the power 4 and replace the value, and got the answer is 4 by 15 into 1 minus 1 by x cube to the power 5 by 4 plus c. So that's where end your unit 2 syllabus. Next class we will be doing with unit 3. Till then, take care, have a nice day. So back end you can close it now. Ritik, back end you are there? Ritik.